going to talk about rate of change. So what is rate of change? So rate of change is the rate at which one quantity changes in relation to another quantity. I got some kind of just tentative examples down here, kind of, sort of. How fast your feet or your position changes relative to time, seconds in this example. Same idea here, miles per hour. So how fast, how many miles we're traveling per 1 hour, all of those kind of things. How many, you might say, how many marbles are in per bag as we chunk bags in a pot. I don't know. Whatever. Let's look at some examples with math on them so we can see how to do problems related to rate of change. We're going to tie directly into when we talk about slope here real soon. So our first, that's a mess. Our first example, we got a graph here. The graph shows the changes in height and distance of a small airplane. And we're going to find the rate of change from point B to point C. So we've got the vertical position right here in feet. So we're starting out at 2,000 feet, and then we're flying along, staying the same height, but moving along horizontally at the same height. And then we fly up and still going along, and then fly down and all the things. So this airplane's flying through space, right? So we want to see what the rate of change, how fast is the plane changing its position from point B to point C. So when we do rate of change, what we do is we do the change in Y, so the change in the dependent variable, so the change in Y, whatever that Y is, in this case it's vertical position, over the change in X. Change in X, right? So in this case, we've got the vertical position. So the vertical position, change in vertical position, over the horizontal position, right? So what we do is we take the final vertical one, so the final, we'll call it Y for ease, minus the initial Y, over the final X minus the initial X. So let's see if we can figure out what that is here. So their final, and usually this will actually work either coming or going, and you can actually do initial minus final, but it's just best practice to keep it this way, keep all the things lined up and know what we're doing. So I think about the initial as being the leftmost and the final as being the rightmost. So we're going to make the C the final. So this is the second position, and then the first position be the first one right here. So what is the final, the ending Y part? Well, it's 2,400. Again, we're just looking at, for the top, we're just looking at the up and down, right? And so that's where this is. If we were to draw a dotted line over here, we're at 2,400. So 2,400 minus the starting position of the 2 points we're looking at. So we're looking at that point B. So the starting position, we already kind of have a dotted line dotted in there going to A. So minus 2,000, right? Over the final X part. So where did it end up on the X? So we're going down here. So we got to figure out what we're counting by. So we're counting by 200. See, 200, 400, 600, 800. So 800 minus the initial position. So at that B point, what is that? So that's 200 and then 400. Now we need to just subtract this here. So 2,400 minus 2,000, we get 400, right? 800 minus 400 is 400. 400 divided by 400 equals 1. So the rate of change in this particular problem between point B and point C is 1. 1 vertical foot for every 1 horizontal foot. And that's just the change in here, right? That's just the change in this little zone in this section, right? This one actually has got all kinds of difference rates. When you kind of go through several different grades and you get all the way up to calculus, we'll learn how fast the rate of change is changing and all kinds of things. And it's called the derivative. And we'll do all of those fancy schmancy things. But for now, we're just looking from these 2 points and for consistent things. Let's look at something that doesn't have a graph. What about one with a table? So the table shows the amount of money that Joshua earns working at a state park for the summer. We're going to find the rate of change here. So we're going to use that same sort of formula. So we're going to do I'm going to write this. This is going to kind of give us some thing for the future. So our y2, our second y, that final y, minus our first y, right? Same as before. And over the change in x. So the x2 minus x1. So the final y in this case on a table, I usually do the lower one. This is the second one, and then this is the first one, right? That's as we go from down to up. If we're going the later to the earlier, that's just how I do it. You can switch it and you'll actually get the same answer as long as you switch both of them, but that's just for consistency and getting stuff in our head good. This is a great plan and a great way to do it. So the y is over here, right? So the final y is 85.5, and then the initial y is 76 over 9 minus 8. So the denominator is real easy, right? The denominator is just 1. That's going to make this easy peasy, right? So now we're just going to subtract the top. Now that's got some decimals and some weird stuff. You may not be able to do that in your head. You can do it in your scratch paper, but at this point, we're getting used to using our calculator. So grab your calculator, punch that in there. What do you get? So 85.5 minus 76 equals 12.5. So $12.50 for every hour he worked, right? So the rate of change is $12.50. And that's it for this topic. We're going to continue diving and we're going to get a little more abstract and add some more things and learn how to graph lines in some other ways and all that kind of stuff. But that is it for this lesson. Thank you. Have a wonderful day. Goodbye.